Alright folks, here's the notes for section 7.1 and 7.2. And in these two sections, what we're going to do is we're going to start talking about volume of three-dimensional shapes, which is the space inside the shape. We did surface area in the last chapter, and that's a bit different. That would be the material it takes to build the three-dimensional shape. But here we're going to start talking about the space inside the shape. Okay, so that would be like the amount of soda inside a soda can. That's the volume. And the surface area would be the amount of aluminum it takes to build the soda can. So they're different things. Volume has to do again with the space inside the shape. Okay, the first 3D shapes we'll do are called prisms, and we did surface area for these. So again, the formula for the volume of a prism is the base area times the height. Now we have to be a little bit careful here because the base doesn't always refer to the bottom of the shape. The base refers to the two sides that are parallel, which means they don't ever intersect each other, and congruent or identical. So in this case, the bases are not on the bottom. They are these shaded in trapezoids here. Okay, and the height, again, it may not be how tall it is. The height is how far apart those bases are. It just depends on how the shape is oriented. The bases may not be on the bottom. Oftentimes they're in the front and the back when they're given to you in a problem. Okay, so we find the area of the base, which in this case would be the area of the trapezoid, and then we multiply that by how far apart those bases are. Okay, so it's a little tricky sometimes. We'll talk about boxes in a minute. They're sort of a special case. But you'll have to really pay attention to figure out what the base shape is before you go to find the volume. Okay, so we go and find the base area, times that by how far apart the bases are. So here's an example here. This is a trapezoidal prism. Again, the bases are these shaded in trapezoids. And so what we're going to do to find the volume is we're going to find the area of the trapezoid. Okay, hopefully that looks familiar. I'll go over it in a second. And multiply that by how far apart the trapezoids are. Okay, so to find the area of the trapezoid, we take the two sides, the two parallel sides, add them up and divide that by 2, and then multiply by the height of the trapezoid. See what I mean about the vocabulary? It gets a bit tricky. Okay, so area of the trapezoid is 12 plus 6 divided by 2 times 4. That's how tall the trapezoid is. And then we're going to multiply that by how far apart the trapezoids are, which is 10. And we work this out a bit. 12 plus 6 is 18. 18 divided by 2 is 9 times 4. And then we're going to multiply that by 10. 9 times 4 is 36, times 10 is 360. So area we use square units, but for volume we use cubic units, which is this little exponent of a 3. So the volume of this trapezoidal prism, is 360 cubic centimeters. Okay, one more time. Find the area of the base shape, multiply that by how far apart those base shapes are. Okay, so let's look at a box. A box is an easy case. Okay, here's one here. And for a box, all you got to do to find the volume is just multiply the dimensions together. The length times the width times the height. Okay, so here's one. It's 3 feet by 2 feet by 5 feet. We're just going to multiply all those together. So I wrote it out a little differently here, but it's the same thing. So 2 times 3 times 5, and that's 6 times 5 is 30. So the volume of this box is 30 cubic feet. Again, it's just length times width times height. Okay, let me take a second here. I should have written that down, and I will. So that's just length times width, times height. Okay, length times width times height. Just multiply all the dimensions together. And there you go. Okay, the other shapes we're going to do are cylinders. And cylinders are also pretty straightforward. It's the same principle really. We find the area of the base. Now the base of a cylinder is a circle, and the area of a circle is pi r squared, and then we multiply that by the height, or how far apart the circles are. So the formula to find the volume of a cylinder is pi r squared times height, or 3.14 for pi, times r times the radius again times the height. Again, r is the radius. I'll add that here too, r equals radius. Sometimes you might be given the diameter in a problem. Make sure and divide that by 2 to get the radius, and then use that when you do your calculations. Okay, so one more time. It's pi 3.14 times the radius times the height to get the volume. Okay, here's one here. And again, I hope this is pretty straightforward. The radius is 5 inches. The height, or the distance between the circles, is 12 inches. And so we're just going to plug that in. We got pi times 5 squared times 12, which is 3.14 times 5 times 5 times 12. And when you work that all out, you get 942 in its volume, so it's cubic inches. You could also write that as CUIN, cubic inches. I prefer the little exponent of a 3 because it's a little quicker and easier to do. Okay, so that should get you through the first couple sections of Chapter 7. Again, there's a few nice examples in the textbook, so please take a look at those also before you start your assignment. And if you have any questions, let me know. Thank you very much.